Hello everyone, it's August 7th. Alright, today we'll have some background noise, but that's fine, let's get it started. It's also kind of late today, so I have to really refresh my head in order to get this done. Alright, let's see. Palindrome partition 2. Alright, given a string S, partition S such that every substring of the partition is a palindrome. Return the minimum cuts needed for a palindrome partition of S. Okay, the palindrome partition for the first one, AAB, so we're going to partition after AA. The one cut, a zero cut, one cut, okay. So we have 2000. And man, string is always something I don't quite like. Alright, so given a string S, we need to partition it. So what we have is a string. Well, look at just AAB, for example. So we need to partition the minimum cuts needed for a palindrome partition of A. The minimum cuts. Okay, so a cut will get the string into smaller parts. So each part has to be a palindrome by itself. I mean, we can check for palindrome. That's not hard. AAB. So minimum number of cuts. Dynamic programming. Let's try dynamic programming. So how do we dynamic programming? So we can cut in any position, right? Let's see. If I have the AAB, so any string, right? Any string. Let's say palindrome has to be palindrome. Oh, look. So because every substring has to be palindrome, so there must be a palindrome at the start, right? Therefore, if it's something by itself, that is a palindrome, right? So basically, we're gonna go from the front, and then we can say we cut out the first one, and we find the minimum number of palindrome for the remaining, right? So we cut one out, and then we find the remaining smallest, the minimum cuts needed for the remainder, and then we plus this one. That will be right. So that's one way. Another way is just keep going, right? Keep going until we find the first palindrome, right? Until we find. So like each time we find a palindrome, we need to cut it and then find the remaining. Each time we cut it and find the remaining, right? Yes. So that means if it's by itself, we can cut it and do the remaining, right? If then the remaining will just repeat the same process. So we cut it first one and find the remaining. And I'm pretty sure that we can use dynamic programming by the start, the low and high. Right? We can say low and high can be in the matrix, and then we can say the number, right? So we know, right? We know if we have on the rows, on the rows, let's say that's 0, 1, 2. I'm trying to recreate this, right? 0, 1, 2 is on the rows. We'll say that's the low, and on the high, let's say that's the column, right? High 0, 1, 2 on the column. So we know everything by itself is good, and that's a zero. It's a zero cut, right? That's a zero cut. It's a zero cut. So from 0 to 0, it's 1 to 1, it's a 0, everything is 0. Now actually we only need, I think, 0, 1, 0, 2, 0, 1, 0, 2, 1, 1, 1, 2. So we only need the upper half, right? Only in the upper half. So now 0, 1, so we're trying to find the minimum for 0, 1. And to find 0, 1, we first check if 0, 1 is a palindrome itself. If it is a palindrome itself, then there's a zero cut, right? That's the smallest. So that is a zero cut because AA is a palindrome. So say 0, 1 is a. If it's not, then we have to look for 0, 0, right? And then look for 1, 1, like because 1, 1 is it's a zero cut. And then we cut 1. That will be a 1 cut. Right? That will be a 1 cut. But now AA, so it's a 0 cut. Now we're looking for 0, 2, right? So 0, 2. So to do 0, 2, what we need is we want. Alright, 0, 2. We have many different ways to do 0, 2, right? We can do 0, 0, like for 0, 2. For 0, 2, we can do a 0, 0 and 1, 2, right? We can do 0, 1 and 2, 2. We'll have 2 different scenarios. So 0, 0 and 1, 2. But we don't know 1, 2. Yes, we need to find 1, 2. How to find 1, 2? 1, 2 is this, right? To find 1, 2, we check 1, 2. Is 1, 2 a palindrome by itself? The answer is no. So we have to cut here. So we say this is 1, 1 is a 1, 1 is a palindrome. So we say for B, for 2, 2. What's the smallest? It's all 0. So that's going to be a 1. So that is a 1. So 1, 2 is 1. So for 0, 2, we'll go 0, 0 and a 1, 2. So 1, 2 has a 1 cut. 0, 0 will take a 1 cut. So that will be 2 cuts. So that will be a 2. So if we go 0, 0, 1, 2, that will produce 2 cuts. How about if we do 0, 1 and 2, 2? So 0, 1, we find 0, 1 is a 0 cut, right? And 2, 2 is a 0 cut. So this one altogether will give us a 1 cut. So the answer is a 1 cut. So is that how we're going to do dynamic programming? So we go diagonal. We have to fill it diagonally, right? Fill it diagonally. So given any value, right? Any 0 to n, we're going to find 0, 0 to 1 to n, 0, 1 to 2 to n, 0, 3 to 3 to n, and all the way to 0 to n minus 1, n minus 1, no, minus 1 and n to n. Right, we find all of this, and in order to find all of these, we have to, if we like build up, it has to be 0, 0, 1, 1, 2, 2, 3, 3, all the way to n, and then 0, 1, right, 0, have to find 0, 1, and then 1, 2, 2, 3, right, so it's all on the diagonal, right, all on the diagonal, 0, 1 is relying on 0, 0, and 1, 1, 1, 2 is relying on 1, 1, and 2, 2, and 1, 1, and 2, 2, because those are all, so everybody is relying on the lower ones, like 1, 2 is relying on 1, 1, and 2, 2, right, and 0, 2 is relying on 0, 0. Oh, the runtime can become huge. I mean, everything we'll have to do 3 times. That's only square. I want to give it a shot. Maybe that is the way to go. Huh. Alright, let's try it. Let's get a new window out. Oh. Hold on. We need to... Let's try it. It could be, but I am not 100% sure. As always, this type of problem is always a little bit hard. And today it's also a slightly more complicated situation. Alright. So what we have is DP, right? DP, let's just say DP is going to be, everybody can be 0 cut times line s. Let's call it line s, n equals line s. Right? Times n for n in for underscore in range n. Right, so that's the DP. And then the diagonal is already set, so we need to find all the other diagonals, which means what we're gonna go is, alright, so it's 0, 1, 1, 2, 2, 3, all the way to n minus 1, n, right? And then 0, 2, right? 1, 3, all the way to n minus 2 to n. So how? So I is going to be go from 0 to 0 to. Oh my! This doesn't seem to be. This doesn't seem to be that simple. Now that's O n squared. I'm afraid 2000. I'm afraid it's going to be O n squared. O n squared. We have to go through every single cell, right? That's O n squared. But for each cell, the runtime is not O1. For each cell, the runtime is going to be ON. So the total runtime will ON tripled. I don't think this is gonna pass. Alright, we're gonna try. I'm gonna try. So how do we write a loop? So 0 all the way to n minus 1. Right, 0 to n minus 2, all the way, eventually 0, eventually it's going to be 0 to n minus 1, right? So, because eventually what we're asking for is 0 to n minus 1. If it's 0 to n minus 1, which means the difference between the two is the length, right? The difference between the two is the length. So it's a length, So for that's k for k in range, k can be ranging 2. So I'm starting 2 all the way to n plus 1. So that's the range of k. Right? K can be 2, 3, 4 all the way to n. Right? And then for I in range, I gonna be range from 0, right, all the way to n minus k, right? Because let's see, k equals 2, k equals 2, so I gonna go all the way to n minus 2. Yes, so I gonna go to n minus 2. I gonna go to n minus 2, so k is 2, n minus 2, yeah, that's correct. Right, so that's for I, I guess. The J is determinant. Right? J is the determinant. Okay, so J, let's say J can equal to J can equal to, as we know, J minus I plus 1 equals K. So J will equal to K plus I minus 1. So J equal to K plus I minus 1. So that's J. So we have J and K, right? So I don't have J and K, we have the I and J. So I and J represents the cell, right? So now we have to compute. Basically we say if from I to J, like if it's, so say if, right, if, actually, let me think, yeah, if S, let me say I to J, right, I to actually J plus 1, because J, we're using J, which is an index, right? So if S this equals to S I to j plus 1. So I to j plus 1 is going to be substring, right? And then this thing reverse, which means if I to j is itself a palindrome, then we say it's dp, and we don't do anything with dp, because dp is already 0, right? So we just say if it's not equal to, right? When it's not equal to, that's what we have to do. How do? We're going to go from the start, right? So we have j and k, with I and j, right? So I something something and then to j position at this position. So we're going to say I minus 1 to j, right? So we're going to be I. So we have a k. So we need a new one. Let's say p. Right? So p is going to be the ending. So which means we're gonna go we have to do the maximum, and then you know what? Let's import math. Or not, or we just keep a 0 and then we just let's just no, we still need a math. So we're gonna say temp equals math.infinite, right? And then we're gonna try to check on every single one all the way to the not all the way to the end, all the way to the one before the last, right? So this, so we're gonna end at this, and then this, and then this, and then this. We don't end at this because at the end we already checked. So we're gonna say an and here. So this is p. So p, right? I'm gonna say for p range I plus 1. Right? Starts from I plus 1. We're gonna go all the way to j. So if we go to j, then it will not take j, or take j minus 1, right? That's all the p value will take. Okay? So among these, what we're going to do is temp, right? And then equal to minimum temp, right? I want to say dp, I, right? I p minus 1.
One of them might not be clean, but
p minus 1, right? Because p is we start from I plus 1. I plus 1 all the way to j, so this is j minus 1, right? So we're going to say I and p minus 1, right? Plus dp, p towards j, right? Towards j. So we know this plus this and plus 1 because of an extra. So temp would be this. So after we run through all the p, then we get it. So then we're going to say dp ij or equals temp. Actually, no, we don't need a temp. We'll just set dpij, right? dpij, set it to math.in. And then instead of just this, we have dpi and j. Minimum this and this around everything, right? So once we're done through all this, we can just return, right? Return dp 0 to n minus 1, right? So that's okay. Now I have fear that this is not going to pass because of timing issue, but we'll try. AAB will output 1, A will return 0, and AB will return 1 cut. Right? Oh, 1 cut, it sounds like a lockpick and lawyer. He always said, oh, this is a 1 cut, this is a 0 cut. Alright. Nope. Well, the first one is not passing. Something is not right. I did add one though. Let's check the DP table. DP. DP was 0. That is interesting. In range 2 to n minus 1, n is 1 to 3, it's minus 1 to 4, so range is 2 to 3, right? It's 2 to 3. So I is going to be 0 to 3. So I have to take 0. I have to take 0. I is 0. J is 2 plus 0. Minus 1, J is 1. Right? So I is 0, J is 1. I is 0. J is 1, yeah, that's correct. I say that J is 1. I have to go to 1 too, which means this one's actually not right. So it should be n minus k. N minus k. Oh, wait, it's wrong. K is 2. Right? K is 2. N is 3. 3 minus. I think it should be plus 1. Because the I. So K is the length. K is the length. K is the length. That's how far you can go. Let me see. So you can go all the way to, right? And then this is now K is 2. Oh yeah, it has to be plus 1. Otherwise, okay. So this. Oh no. What the heck? This is wrong. Didn't do any of this. Alright, so we have I. Let's see. What do we have on the I and J? Print I and J. Right. I is 0, J is 1, I is 1, J is 2, and 0, 2. Yes, we got everything. So first is 0, 1. So 0, 2.
I think both of them might be.
So 0 to 2.
So the one that was clean was the one we gave up.
Yeah, 0 to 2 is.
So both
Actually,
of them I think are
see this.
full sized.
Okay, 4.
Oye,
Zero, 0. Yeah, this is 0. That's correct. That's correct. So it's this one. 1, 2. 1, 2. 1, 2 is the issue. So 1 and the J is 2. So basically 1, 3. 1, 3 is. It's AB, right? AB, so that's not. So we do this. So this is 1, 2 becoming that. And P range I plus 1. Okay, I plus 1 to J. I plus 1 is I plus 1. I plus 1. I is 1. 1 plus 1 is 2. 2 to J. 2 to 2 is nothing. Nothing come out. So that is not right. So it should be from I to J. Right, I to J.
I'll go bring it.
So if I to J, then DPI J, DPI, and P is going to be I. Right. And this is that has to be P plus 1 to J. And that has to be P plus 1 to J. Yeah. This one's how we expect. Okay, that's how we expect now. Alright, so these are correct. We need an interesting test case to give us some insight. Alright, so we're gonna do I don't know, something like this. I don't know, just random string put in. Okay.
You can get the steamer if you want.
Looks like everything is A. I can totally see this as a test case. There's tons of A's.
If you take care of the steamer and you don't leave it here.
Oh, that's some regular. Something random just along the way. Oh, no. Right, something weird. Okay. Let's try it. Pending. Judging. Come on. Come on. Come on. Come on. Come on. Come on. Yeah, I think I timed out. Either the wrong answer or timed out. Timed out. Okay, so the answer is correct. That's reassuring. At least we have some baseline to work with. Oh my god. This is, let's see, past 27 out of 33. Okay, so this one times out. It's correct, but we timed out because it's all in tripled. That's what we fear. TLE. This is ON. This seems to be ON tripled. This seems to be ON tripled time complexity. Alright, so now the goal is to reduce. How do we reduce this? I mean, how long does it take for this one to run? Does it take a long time? Is that 2,000 characters? Ew, that took way too long. Okay, so I think the idea is right. It's just we shouldn't go through every single combination here. I mean, we go through every single combination in order to find the minimum, right? Maybe if let's say if this doesn't satisfy, which means the substring itself is not a it's not a palindrome by itself. When that happens, probably timed out. Oh, 6 seconds. 6.7 seconds. So the string itself is not a palindrome. And then the minimum possibility is the minimum possibility is a one cut, right? Which means there's which means between I and J, right? Between I and J, there exists a certain position such that I to this position P and P plus 1 to J, right? So these two both are palindrome, right? In other words, what we're looking for is the minimum value, minimum two values, right? The minimum two values from I to I, and I plus 1 to J, I to I plus 1, I plus 2 to J, all the way to I to J minus 1 and J to J. So among all these, the smallest sum of these two values. Now, the good part is we know I, which is because we're just changing J, right? We're just changing J, so that's in a row. And the other one is we know J, and we're changing columns, and the other one we know J, so we're changing rows. So this means we're looking for like a row I, right? And then this column J. So row I, so I from I to I all the way down to J minus 1, right? To J minus 1. We're going to find the smallest value. To find the smallest value, not really the smallest value, but is it possible to make this faster? We know II is a 0, II plus 1 would be at least a 1, at least a 1. And we just have to go through every single one in order to find the smallest sum, right? Smallest sum. How do we find the smallest sum? If this, the smallest and smallest of this, like if we record, let's say, we recorded all the 0 cuts, right? If all the 0 cuts we have found so far, and we have I, and then we have a list of I and J, right? For everything we find so far, we put into it, and then one cut we put into it, and then what we need is just to look at I, right? Look at I, and then if we look at I, and we find which one is a 0 cut, and then we take that one out, right? And then to check, so by looking on I need to see which column is going to be a 0 cut. And then once we find out, we go take a look into the other one. We go into the, let's see, am I still streaming? Yeah, I'm still streaming strong. Okay, so what I'm saying is if we can keep track of all the columns with a given given row, that would give us 0, right? So given us a 0, so we find a J, right? And then from that, not J, from that P, right? From that P, we can see P plus 1 to J, see what value that one is. See if it's a 1, if it's a 0. If it's a 0, then we find it. If it's not a 0, we keep looking for the next one, right? And then after we look through all of them and they're no good, then what? That's not all the ones. The thing is, if we want a 1, it has to be 0, 0, right? So both has to be 0 to give a 1.
A mí no me molesta la tela.
It's all you.
It's a row, and that's a column, and a row and a column is connected.
11 megas. Wow.
I mean, I'm trying to fix. I mean, it could be. I don't know. We're just playing around. I don't know how long. This is taking a long time, right?
Si ahora tener un shelf para tu wallet.
Yeah.
Am I
Nice, right?
recomputing this part? This is what I'm also trying to
¿A ella se
think.
le
Am I
ocurrió?
recomputing? So
See?
I
Yeah, you like it?
okay is a certain amount. Maybe I'm recomputing this. What I'm thinking.
La dejas por todos
I
lados
don't
y luego
think so
no la
though. So
encontrabas.
I that
What? No? I mean, this is...
J is going to be this.
I don't know. She just thought it looked nice.
I and J are all different values for each one of them, I think. I and J are different values. I and J are different values. I mean, the last one we have to... There's gotta be a way to make it O n squared. This O n triple is definitely not gonna work. Can we get... I mean, this is looking at these two. Can each one just looking at... Like, if we're looking for 0, 2, right? Can we just say 0, 2 can be determined by 0, 1 and 1, 2? Is this possible? 0, 2. What do you mean by 0? It cannot be determined by 0, 1. It's determined by 0, 0 and 1, 2. That's the thing, it's determined by 0, 0 and 1, 2. If it's 0, 1 and 1, 2,
Regular.
well, not gonna work.
Sí, o sea, hubiera estado peor, o sea, pero es que es un proceso lento. Lo que más me preocupa es no ir a trabajar a la oficina. ¿Verdad?
Pero si tienes... ¿No será posible tener donde poner tu piernas straight en la oficina?
Por poner un asiento, lo que está
Yeah,
pasando.
ponlo así straight y ya puedes...
A ver cuánto
A different way
aguanto.
of
Ajá.
thinking.
I think it'd be fine.
How about we isolate?
Pues sí, porque ya llevo
Analysis,
3 semanas sin ir y
I just don't want to give up this idea.
meses de...
That seems so neat, right?
If only this was still COVID, then it'd be normal.
Don't know.
Ah, no, pero ahí ya regresamos.
I mean, this part does take a long time.
¿Cómo fue?
Let's see if we
Ay,
maybe micro manage will make it
June?
faster.
junio. creo.
Let's see if we only copy once.
Mediados de mayo, final de... Algo así.
Let's just say we copy once and
Y
say
luego
10
me pasa
and not
esto.
equal to 10. I don't think it will make a difference, but
Ay,
let's
sí.
see. Instead of 7,
Yeah, it's okay.
6.7, maybe you can
Ah, no,
cut it down
no, la
significantly.
voy a aplicar a los trabajos acá, anyway. Ya es lo que estaba hablando con ustedes,
No,
también le
let's
dije
just cut it down
a
a
las
little bit.
vietnamitas.
No, that's
Oh,
not.
sí, aquí cuando trabajo de computadora rápido.
That's not the reason.
So you keep going with it.
¿Por qué será que todos los salones casi de uñas son vietnamistas? Bueno. Algunos son chinos, pero la mayoría son de Vietnam, everywhere.
Let's see. Let's just take a subset of this.
¿Por qué todos de landscaping son mexicanos? ¿Por qué todos los cocineros son mexicanos?
I don't know.
No sé, pues hay certain industries donde... Si tú eres un vietnamés
Give it a
sin
try.
trabajo y llegas
18.
Aprendes a hacer uñas.
todos tus
Let's take
contactos y
a look.
amigos y
Hacen
network
uñas,
hacen
ajá.
uñas, pues te contratan. Ah, ven a trabajar por mí.
Print.
Don't work for me, don't worry.
Sí, hombres todos hacen uñas ahí.
Va a ser más
That's a lot.
difícil ir a los mexicanos y decir, a ver, ponme a hacer los landscaping, porque no te conocen.
Doesn't really help much.
O sea, no sé cómo empieza, pero ya que tiene, está establecido,
No,
pues,
It doesn't have much.
It makes sense, no?
I'll cut it shorter.
Ay, sí, Dios
Let's
santísimo.
cut it shorter.
¿A qué hora se hace la pizza, Miguel?
5.
¿Y a cuánto tiempo se hace
21.
de la mansión a la pizza?
Like
No, that's a
15
pounding room.
minutes, less than that.
And then all the way to here. To here. These are not pounding room.
Okay.
Let's have a 0 here. A 0 this, right? So we can say we
I
find
don't know
the
how to
pounding
tell you guys. I don't want to tell you.
Don't see how.
No.
I mean, there'll be
You want to go to sleep?
No.
there'll be patches that have no pounding room in it.
Ve.
It's like
No tengo
these.
matriz, por favor. No, después de que desperté de la siesta, me duele mucho la
0,
garganta.
1, 2,
Bueno, no
3.
mucho, un poquito.
So from 3 to
Un poquito nada más. Pero no es copia, me acaban de hacer
3 to
un
8.
test.
0, 1, 2, 3.
Me acaban de hacer un test.
3 to 8.
No quería decirlo, pero dije es irresponsable que no les diga.
5, right?
Porque
It's 5 cut. So everybody,
sí,
and
o
then we
sea, apenas
65
empezó
plus
después de que
32.
desperté del nap.
You see, these we don't have
Pues
to
nada,
compute,
desperté con
right?
la,
You see this? 1, 2, 3, 4,
con
5,
la
6, 7.
garganta dolorida.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 1, 2. So on these we don't have to compute because we know from this
Ay, me haces un favor.
going down, that's not a pounding drum.
Puedes apagar esa luz y esta luz. Ah, no, antes está cortado. Sí, bueno, la de la
And-
cocina.
And we will also
Ahí
know
ya
this.
está el carbón.
If we find the pounding drum, right? And everything inside also contains a pounding drum.
¿Vienen?
Therefore, I think the goal should be first identified linearly where the pounding drums are.
Did I wake you up last night, Chrissy?
But isn't that the goal? But isn't that the goal?
I'm very quiet.
I mean, okay, so what we can do is, from the start,
Probably because these doors are really creaky.
right? And from the start,
Doors are what?
Really
Like-
creaky.
we
Oh yeah,
can
the bathroom.
I feel
Bueno.
bad every time I open and close either the bathroom or the bedroom. They're really creaky.
look for the
Ahorita
longest
si no,
pounding
que así.
drum.
No, ¿cuál apagador es
The
el de la
longest
cocina?
pounding
niña?
drum is a string. The longest pounding drum
Sí, 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 cuando se
is
acabe
a
eso.
string.
Es un
How do we
relay
do that?
directo.
The longest pounding drum in a string. Let's say we can find the longest pounding drum in a string, right? And then we know that part is done. So for the remaining parts, right? Remaining parts, we can continue finding the longest pounding from the remaining parts. Longest pounding drum.
El negro de adelante
Can
no
repeat
es
it,
de Estados
compute
Unidos.
longest
Sí, ese
pounding
no,
drum.
¿verdad? Sí, pero tiene anaranjado. Y azul.
Yeah, because that is the minimum cuts, is to use the longest pounding drum. Actually, I don't know about that.
Ah, sí.
It could be the longest pounding drum,
O bueno, que ahí.
but it could also be if I do the longest pounding drum. Yeah, if I do the longest pounding drum, maybe I'm omitting. Like I can do like 2 smaller pounding drum will actually be better than 1 longest pounding drum.
¿Él es el último?
But if we know that a string is not a pounding drum,
Falta otro.
and it all doesn't not contain any pounding drum either,
Bueno.
how do we tell that?
Ooh, look at that gap.
Huh?
You're done?
Dude, he's leaving in the dust.
Tough. Okay.
Oh, sí, fue el último. Sí, fue. Por mucho.
Sí, muchísimo.
Alright,
It was a world record.
back at it.
¿Quién ganó? Ellos, ¿por qué están contentos? Ellos fueron los que ganaron.
How do I tell
No, en ese
if
momento
a string?
desvié la vista y no vi quién
I
ganó.
mean, now I remember there are some methods
No lo
to
puedes usar.
do palindrome faster, but I don't want to do those. It's tough for me to. I don't remember basically.
¿Usted? Otra vez se volteó.
Sí,
But this one, if we don't check one by one, what can we do?
Ahí, ajá, iba ganando los Estados Unidos.
Can we then jump?
Esto no es tu-
Wow.
Dude, look at
Sounds
that.
like-
Really close. Just left him in the dust.
Sí.
That's like LeBron James.
¿Te pareces?
And from here to any
Entonces, esos
position,
ganan
we're
segundo
gonna
y
take
tercero los
this.
anaranjados.
Apenas
Right.
pasaron la noche, no segundo.
Yeah, because of the
Wow,
zero.
no, les llevó por un montón.
Sí. Ves verdad.
Wow, even to find.
I turn off the light.
Sí, oye, también pura la de la cocina, ¿no?
Una es la ventana.
Y la de la cocina. Sí. Bueno, ayudan para your
Yes.
Mira,
¿Cuál es la de
Lo da
la
la
otra
pena.
a lo mejor?
Yeah.
Thank you.
Thank you, guys.
mira el piso de atrás. ¿Eh?
So if we have the starting point, we know
¿Viste el
from
piso de
start
atrás? En el tercer
to a
lugar.
certain point, it is a palindrome. Maybe it's the check or palindrome. This one is tough, and I'm not in environment that's very helpful.
Pues guarda, amigos.
Sí, eso dije, ¿no?
Sí, correcto, estuviste correcto. Muy bien.
Alright, I'm gonna set a timer. Let's see where we are right now. We're at 47 minutes, so I'm gonna give it a little bit more try.
Te vas a take COVID.
It'll take me 10 more minutes. If not, I'm gonna go for the solution.
Me hice el test de COVID.
¿Cuándo?
I vaguely remember some methods to palindrome, but
A ver, ¿hace cuántos
I don't
días?
know. I mean,
Ay, no me empiezan a dar.
No,
I'm
you're
getting,
okay.
A ver.
I'm getting
It's
stuck.
far more, if you are sick, it's far more likely to be not COVID than something random.
Okay.
No.
Me acuerdo que les mandé un mensaje que dije era
Start.
negativo, right?
Right? If we have a start,
So I can see there.
and I'd think about maybe greedy can work.
¿Les gustó
I
a mi
think we
Snoopy en el
At
avión
a certain
diciéndoles
position is
adiós?
going to be
Sí.
the first palindrome, the longest first palindrome. And I say if we don't take it, then we just do split, and then we do the remaining. And we know the remaining gonna give us the smallest. This is gonna give us the smallest. And this might not be a palindrome. So this actually gonna be worse. Right. So if we save this, it can give us a smaller
Ready?
than this.
Night.
So yeah, I think it is to find the longest palindrome at the start, and then we cut it right there, and then we find the longest from the start, and cut it. So then this question turn into to find the longest palindrome. The longest palindrome. How do we find the longest palindrome? Can't I just find the longest palindrome in the string? Actually, we have a start. The longest palindrome from start. Actually, we can do it from start and from the end. So we have an A. So we start with A, right? Now what? We'll look for the second one. We'll look for the second one. And if it's not an A, and the second one it's not the same as any of the ones that we have seen before. Okay? Until we find one that is something we've seen before. But if it's a palindrome, then it is required that that value must be either it's equal to the one right before me, right?
Yeah. Oh,
And if it's a palindrome, if we keep iterating, right? If we find a value, any value we see, we compare to the value right in front of it. Right? If it's the same, then we have a chance of palindrome. Right? If it's not the same as the front, so we either compare to the value right in front, or compare the value in front and in front, right? And compare these and see if it's the same. If they're the same, then we know it's a pair. It might be a pair, but I'm just gonna keep comparing. If it's not, then what? Then we still have a palindrome. Right? We have a
no puede
palindrome.
ser. Ya la habían librado.
¿Y por qué corren al principio así como arrastrando
Alright,
los pies?
let's cheat a little bit. Cheat a little. I think if we can find a solution for the longest palindrome starting at the beginning, starting in the second position, we find the longest palindrome, then we might be able to solve this. The question is, how do we find the longest palindrome? So longest palindrome. Yeah, longest palindrome. I might have solved this before actually. Yep, I solved it by myself. Longest palindrome. That's an easy question. The length of the longest palindrome that can be built with those letters. The longest palindrome is DCCACC. Oh, that can be built. That's not what we're looking for. That's not what we're looking for. We're not looking for the longest palindrome that can be built. We're looking for the longest palindrome substring. Longest palindrome substring. Brute force O and tripled, which is basically what we have. 3 nested. Yeah, that's bad. That didn't go right.
Fue 22 de julio. Cuando hice la
That's
prueba del
O
COVID.
squared. Even if we have O squared. O squared. Let's see, what's the... It's filled in bottom matter. Substring is palindrome, otherwise false. To calculate the table. Check the value of the table. I plus 1.
22 de
That's the
julio. ¿Cuántos de
below. Wait, what's IJ? I think it's the index. J minus 1. If the value is true, it's nice.
Fueron 2 semanas.
Oh, okay. It says check the value of table I plus 1. I plus 1. So we're given IJ. If I plus 1, J minus 1 is, then we check if this, then that's true.
No dice tu papá que cuánto
True or false
tiempo
in
después
case.
del COVID en la vera, después de la casa, y le dije que nada más 2 semanas y solamente los
Okay,
que
that
pudieron
is
sacar a él.
palindrome. So basically we're filling the table.
Que si no se asustan sus la empresa y que todo
So
lo que
by
se
running
hace cerrado.
this, we will be able to know where the palindrome is. Right? That's what we do. By running this, we know where the palindrome is. Okay, so give a string. We can run this algorithm. So to get a counting drum out. And then the longest counting drum would just be the value. So yeah, it's the same as what we think, right? And then this is just true or false. And just looking for the longest counting drum. Okay. Okay, so this is saying, given a string, we have this, right? And then we need to find the longest counting drum. Basically, we run the algorithm. And we say, to know if this is a counting drum, we just know, to know if I to j is a counting drum.
So, el 23 de julio,
To know I to
¿cuánto
j,
tiempo pasaba?
if I to j is a counting drum, we just need to know if I minus 1 and j plus 1 is a counting drum. Which means we can use this to simplify
O sea, no puedo hacer COVID
this.
todavía.
It's not COVID. Estamos vacilando.
But this is to record. We're recording different things. We're recording different things. But by running that algorithm, we will be able to know the pattern drum that exists. Right? That's the benefit. So if we run that, and then we go from 0 to find the largest. So we go from bottom to front. On the largest one, that returns a 1. Then from here, on the largest. So every time, let's see. I'm going to the logic. We say that it must be that the front and the end must be the longest pattern. If the front to the end is not the longest, and then if it's not the longest, then we can always find some that it's always longer compared to. So doesn't matter. Okay, I think I'm gonna use this. This is like a. It's a partly greedy. Let's take this as 0, which is TLE, and this is 0, 0, 1. So this one is going to be 0 or false, and then all the 1s and 2s we have to pre-fill ourselves. Right. The 2s, because we don't have I minus 1 and I plus 1. So ij, I plus 1. Yeah, so we'll pre-fill. Let's say for I range and dp I and I. That's true. Right. And I, so I and I plus 1. Right. So I plus 1. So that's 0, 0, 1, 0, 1. Right. 1, 2, 3, 4, 5. So for I and for j, for each I, maybe 0, 1, 2, 2, 3, 4, 4, 5. Right. So I'll just say if I plus 1 is square n and s I plus 1 is equal to si, right? If it's the same, then dp I and n plus 1 equals 1. So this is the pre-fill. Then for I range and for j range.
Mañana le toca su llevar lunch para...
plus
Sí, no ha hecho
0
nada.
or 2. So I plus 2.
¿Oíste, Picha?
Right? That's actually not. That should be I minus 2. I minus 2. Because I minus 2. I have to take a minus 3. Minus 3 plus 2. So yeah, so. Because for each I, we check. For each I check j is this, right? And then, so we're checking 0, 2. Oh, no, 1. No, I think this will be the same as this. Actually, k will be the same thing. K range. And I've got 2 because we handled 2 already. 3.3. So 3 to n. And for I range minus k, j was this, and then this minus I, so k, right? So this is each range. And then we say if dp I minus 1, no, I plus 1, and j minus 1. If I plus 1 and j minus 1 is good. Right, I plus 1, j minus 1 is good. And s I is equal to s j. Friend of n is also equal. Then we say dp ij equal 1. Right. And then we can go in dp print row. Solution is not defined. Solution 1. Okay, so this one says the only is the diagonals all padding room, and the only one is 0 to 1. 0 to 1, 0, 1, 2, 0 to 2, 0, 1, 2, that's the only one, right? So with this, what I'm saying is, what we're going to find is, starting from each row, right, each position, we're going to find the first one coming from the back to the front. That's what we need to find. So what we need to find is here. So the first one coming from the back. Basically, for I in range, no, not for I is 0, right? And we say while I is smaller than n, f j, j will count from the back to the front. So can we do better? Yes, we can. Every time this equals 1, right? And we're gonna push it in. We need to know at each row, right, at each row, what is the largest j, right? What is the largest j? So this means we can have a new dp which just push in the j position, because as you see, we start from small, right? And these j's are bigger. And j just goes, k starts going to be bigger. So k will be 3, right? So I can have a dp for that, and we say we just want to know the largest position, right? So we say longest palindrome per row. I should say longest palindrome. This is max padding position. Max padding position is going to be equal to it's going to be list range n, right? Because for each value, the longest for the hair is itself, right? So I'm going to be here. This is this, and this. If this max composition I, right, equals I plus 1. So after doing this, and then max this I equals j. So every time j is always bigger, right? So once we've done this, we also take a look at the, let's say we'll also print the max parameter position. Yeah, the max parameter position. So as we know the max parameter position, so 0, get to 2. Right, so from 0 we jump to 2. And then, so 0, 1, 2, we know these are the patterns, right? So that's one cut. Get out, it's one cut. And then coming back up, we go for 3. 3 is 3 by itself. Take another cut. 4. Another 4. So we're going to say I equals 0, and this, right? And less going to equal to 0. Right, so what we do, we say I can equal to max power position I plus 1. Right, I will do the next one, and then coming back up, rest plus 1. So let's say rest started with minus 1. And then coming in, we're only going to do one cut. So take the first cut, move I, and I has boom. Now we just turn this to rest. So this is pass. Let's see the others. I'll pass. Let's try this abomination. 273. Okay, this one give us 273. Nope. It's not taking the longest every single time. It's not taking the longest every single time. This does give us some more possibilities, right? So in squared to know where all the padding positions are, and then what we're saying is if we don't take the longest palindrome at the front, so take the longest, then we say it will be better option. If we don't take the longest, then maybe something else can form later on. What do you think? But I think this might be the idea. At least we know where all the positions are. Alright, do we have a hint on this? I don't have any hints. So if I know where all the palindromes are, will that help? Let's see if we can combine solution 0 and solution 1. This tells us, I mean, at least we can check for 01. So what we're saying is we have I to j, right? So from I to j, we know if there's any palindrome inside from I to j, right? We can because if there's any palindrome that from I to j, right? I to j, to j. So we'll have all these. This plus this. So if any one of these is a palindrome, alright, I want to have some hints. This is I feel like out of my current capabilities. I need some hints. Not necessarily a solution, but just a hint. Let's see, related topics. I know it's dynamic programming. I know it's dynamic programming. I don't think I've done this before. Yeah. Dynamic programming. Top down. Clean and concise. So we have a top down solution. So it is dynamic programming, but what, divide and conquer? How would you do divide and conquer? Well, we have a string. We can divide a string in 2, right? And we find a minimum on the left, we find a minimum on the right. And if we cannot add them together, because in the middle, we have to handle the middle. So we divide it in 2. We look at the middle. Right? We have a string. Divide it in 2. But we'll look at the middle. So the middle could be, there could be a spanning, right? That'd be a spanning palindrome. If you find a spanning palindrome, I don't know. Get a palindrome, right? And then the right on the palindrome, and then the middle. You only run it all squared. Be true if string is palindrome. Minimum number of palindrome. substring of I to n minus 1. The other is dp0 minus 1, which is the minimum cuts that need to be made out of string 0 to n minus 1. It seems to be so simple. I'm not looking at a solution yet. From I to n minus 1, instead of from I to j, we say from I to n minus 1, so from I to the end. We say if I know this, if this is a pattern, we take this and the remaining, right? If we want to know the remaining, we take this, remaining, and eventually we're going to go down. So I know this, how many it needs to take. It says dpi, number of cuts from I to the end. If I know from I to the end the minimum number of cuts, right? To know, we need to know this and then this, right? But we have to also compare this to this, and this to this, and this to this. No, I don't understand. Read again. Minimum number of palindrome substrings. The number of palindrome substrings. Minimum number of palindrome. Hold on. Minimum number of palindrome is not talking about cuts. It's the number of palindrome. What is the question asking for?
De la mesita abajo.
The question asking for every substring is a palindrome. Minimum cuts. Okay, so minimum cuts, which means the longest palindrome, which is the minimum number of palindromes, right? So by running the dp of that, we can get all the palindromes. D0 is the number of palindromes. 1 that's the number of cuts, yes. So to find the number, the minimum number of palindrome from 0 to end, right? The minimum number of palindrome from 0 to the end. We need to find the number of minimum palindrome from the 1 to the end. Right, if we have that, and that's the number of minimum number of palindrome. Now we have the minimum number of palindrome from 1 to the end. How do we incorporate to the front then? A minimum palindromes, right? And a number of palindromes. And we incorporate this. We say minimum number of palindromes, right? And then from, if I know this, how do I know? If I know from 1 to n minus 1, how do I know from 0 to n minus 1? If we have the number of palindromes, minimum number of palindrome, minimum number of palindrome, which means if it's a minimum number of palindromes, right, which means the start must be a palindrome. Right, the start must be a palindrome. If the start is a palindrome, then let's see. If the start is a palindrome and we add 1, right, because we only add 1 to it, it could be like, let's say, BBA something something something, right, and then the number of palindrome is just 1, 2, let's say we'll have 3 palindromes, BBA and let's say CCC, right, BBA CCC, BBA CC, right, BBA CC, and we have A, BBA CC. The number of palindromes should be 2, and so we take A out and we define a 1 to the end. That's BBA CC, and BBA CC gives us 3 palindromes, right? Now when we add 1 and A to it, right, add A to it, then what? We need to find if including A will turn something into a palindrome that's originally not a palindrome. Something that's not a palindrome. Because at the start, it got to be a palindrome, and another palindrome, right? So divided into individual palindromes. Now we add something to the front. If that is equal to what we have at the beginning, it's not going to work. So what we need to know is the thing at the beginning, right? The thing at the beginning, where does it end? Right? Where does it end? But we don't know where it ends. I don't know. If DI denotes the minimum number of palindrome substrate. Huh? Now you're saying that is palindrome. We cache is palindrome, okay? Okay, this check might be faster. And then DPI, to I to N, if it's palindrome I to J, wait, what? How is this passing? Mine is not passing. It's literally for J language, you just check every single palindrome. How is my answer? How is this one not passing? What the f? It's literally checking every single palindrome. What? It literally from I to the end. We just check I plus 1, I plus 2, I plus 3. Alright? We check I to j, and then j is 1. Right? Hold on. So from I to n minus 1, we don't know. So we go from I and j. J is going to I. If it is palindrome, then answer equals minimum answer dpg. Yeah, this is exactly the same as what I did. It's between I and j plus 1 to the end. Right? Minimum answer. Yeah, dpi plus 1, j plus 1. Right? J plus 1 plus 1. That's my code. This is exactly the same setup as this. But how is this one passing but mine doesn't passing? dpij. How is this one faster? It caches. Chain range I towards n, palindrome ij. So palindrome caches, and I to and dp also caches. I also cache. I just include that one, but that's only k and I is the same. J is static. J is static. J is determined by k and I. Unless this one. I j plus 1.
Tenía mucha proteína los noodles.
Granted, if I do know
Oh, pero hay cero de
I
proteína.
to
Sigues
j,
comiendo proteína.
still this shouldn't be the at this part.
Sigues comiendo proteína.
It's minimum cuts. dp is the minimum cuts. dpij was minimum. dpij, dpip, and p plus ij. equals the number of cuts and the number of to get the number of cuts. It should be the same concept as the number of cutting rooms. This idea is not right. Probably this one again. That's not right. DPIJ is a number of cuts, name the number of cuts between I and J. Right? So equal to, and this, and then we just cut at each one of them. Cut it itself, cut here, cut here, cut here, cut here.
Pero es que no hay mucha proteína ahí, nada más pedacitos de camarón y de...
I think the only difference is there is no J there. There's no J. Because that in that solution we all the way always going to the end. And we always going to the end. But in here we do not go to the end. Do we not need to go to the end? I'm saying to know
¿Qué?
from here to here,
¿Qué?
from this one to this one, we need, say, from I to J, right? We need to know this plus this, right? This plus this plus 1, this plus this plus 1, this plus this plus 1, right? That, we got it. That's what we do. We start from a length of 2.
¿Tienes frío? ¿Estás 74 euros, no?
¿Cuánto es tu 67?
Starting
Ahorita no sirve de mostrar huella.
from, what do you mean, like,
No se siente frío.
so what I can tell is minimum cuts from any two positions.
Esta japonesa más
And you're
chiquita,
telling
¿verdad?
me that it's not necessary. So we want is from 0 to minus 1, right? If we go from 0 to minus 1, what we need to know is 0, 0,
Ya se me acuerdo cuando el básquet de Kobe Bryant.
1 to minus 1, 0, 1, 2 to minus 1, 0, 3,
Bueno, cuando murió se había olvidado, ¿no?
da, da, da.
con la hija también.
Okay, we need to know all these. Now to know 1, 2 minus 1. To know 1, 2, 2 minus 1. No repeats. Okay. Okay. 1, 2, 3, 2 minus 1. Repeat. I seem to find it. I seem to see it. So everything is going to the minus 1. Okay. Okay, everything goes to the minus 1, which means integer 1, 2, 3, 4. Right? Integer 1, 1, 0, 1.
Ponerle bueno.
Integer 0, 1. Need 0, 0. How do we get 0, 1? How do we get 0, 1? If not, it did not do. It has to be palindrome. What do you mean? If it's 0, 1, yes, 0, 3, 0, 4. If one of them is not a palindrome, then we don't consider it. Which means if it's not a palindrome, we don't consider it. That is. Hold on. What did we do? What we did is the minimum cuts for ij and vyj. What we won't want is the minimum cuts from 0 to n minus 1. That's what we want, right? And what we see is to calculate 0 to n minus 1. That's what we need. We need 0, 0, 0, 1, 0, 2, 3, all the way to 0 and minus 1, right? And for each one of them, we can keep computing. And the beauty is, if 0 something is not a palindrome, then we don't consider it. Why? Because if a certain thing is not a palindrome, why we don't consider it? I don't understand. If it's not a palindrome, because
¿De qué horas te acuestas?
if it's not a palindrome, because in this is when we're looking for the minimum number of palindrome, and we are looking for the minimum cuts, right? We're looking for minimum cuts. See, the first part is a palindrome. For the minimum of this. If the first is not a palindrome, right? If this is not a palindrome, that means it has to be split up. And that means we have something smaller that is a palindrome. That is something we already considered. So we don't have to consider again. Yes. 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 Which means this one still works. This is K is the distance, right? This is a distance. And then we basically just say the length is 2. What is the minimum that we can do? And we say if it's not a palindrome, now this is completely bottom up. Completely bottom up. We need to do something different. So P range. Yeah, it is. It is. IP and then right, it is. But then if it is not a palindrome, then we should leave it as the maximum. Which means K range 2. Yeah, 2. Okay. So for any pair with a known number of cuts, if it's not a palindrome, right? If this cuts is not a palindrome, then it can be cut into a palindrome and something else. And that has been considered already. So if it's not a palindrome, if ij, right? So what we're looking for is from I to j. If from I to j itself is, it's hard to think of this way. It's very hard to think about it this way. Okay, let me try it again. So what we're saying is to find any I to j, right? To find any I to j. If I to j is not a palindrome, right? We say if I to j is a palindrome, then we continue looking for it, the remaining. If I to j is not a palindrome, then we just give up. Why is this solution 0 doesn't work? Eventually is n to the end, right? Yeah, this is like 0, 0, 0, 1, 0, 3, 3 to the end, 1 to the end, 5 to the end, all the way to the end. And I'm going to just push them together. So to compute this, we need to compute. Now the thing is, we only need to compute the ones that is a palindrome, like a 0 to something that is a palindrome. That's all we need to compute. Because if 0 to something that's not a palindrome, we can always split it up into 0 to something that is a palindrome and the remaining. Alright. And this already done before. So 0 to something, if it's a palindrome, then we check the rest. Now we check the rest eventually go back down, so we can build bottom up. It's something to n minus 1, something to the end, right? Something n minus 1, something n minus 1, so we just count the number of cuts that we needed from something to n minus 1, something to n minus 1, something to n minus 1. If something to n minus 1 we have the number of cuts, 2 to n minus 1, 3 to n minus 1, 4 to n minus 1. If we know that's a 0 cut, this it's just going to be, if it's a palindrome, it's a palindrome. If it's not a palindrome, that can be how many cuts? Well, it depends, right? It depends on the number of palindromes. Number of from any position to the end, right? The number of palindromes from any position to the end. If we have to know, no, it's different. That method is able to tell where the palindrome is, not the number of palindromes. To know the number of palindromes from any position to the end. If we know the number of palindromes here, how do we know the number of palindromes adding up to this? Number of palindromes. Well, it's the same thing. To know the number of palindromes from any position to the end. Right? So recursion, we need to know the number of palindromes. Taking the palindrome in front and add a number of palindromes at the end. The minimum number of palindromes. So that is a different way of considering this compared to this. I say it's very different. Well, we're almost 2 hours in, and we still can't figure out why our initial solution doesn't work. Initial solution. I kind of know why initial solution doesn't work, but the recommended solution is the initial solution doesn't work because we are computing the minimum cut of any pair, not towards the end. That's why it doesn't work. But I was trying to convert this, but I failed. I cannot convert. What it's saying is K range, right? K range 2, and I will always be the last 2. And we say from this, to the end, then to compute whether it is, do this, right? Yeah, let's just say this is a 0 cut, right? And then we do it here, and we try to this is a palindrome itself, that's a zero cut, right? If not, I'm going to take this and I'm going to take this, right? Now add one more, same thing. Let me see if this is a zero cut. If this is not a zero cut, I'm going to take this and the remaining, or this and the remaining. And the thing is, when we take this and the remaining, we ought to compute it, right? Because eventually, what we're looking for is the entire thing. So we're going to take this and this, or this and this, this and this, right? And when we say this, we say this has to be a palindrome. This is a palindrome, and compared to this. Because if this is not a palindrome, then we can break it down into palindrome, and the remaining, this is something we've done already, right? So we can build back up. I just say anything in this, it's just going to be this, and this is a palindrome because we already know how many cuts it requires. And then this. By the official, by this. But with bottom up mindset. It doesn't work because we're computing the mean cut for any tail of ij. But in reality, we only need the mean cut for pair I n minus 1. This requirement, this changes, this these cases are not as a computation. For instance, to compute I to n minus 1, we can go through I plus 1 block I plus 1 plus 1 and plus 2 plus 2 and plus 3 minus 1. Right. And the trick is when I plus k is not a palindrome, you can simply skip it because it can be broken down into sum I plus k prime and k prime plus k, where I plus k prime is a palindrome. This breakdown hypothetical situation where I plus k is a pattern with itself. Okay, so the bottom of mindset, right? So db equals class.in times so minus times s times n, right? And db minus 1 equals 0. That's a 0 cut. Now I say for I manage I minus 1, right? No, I minus 2. 2 is 1 minus 1. So like I, and then every time I is I towards the end. Right? So what about j? So j image I to j is going to be I to what for one thing if s I to the end equal to s I minus 1, then dp I equals 0. This is 0 cut. So this is 0 cut. Right. Otherwise, if this is not a, we can actually go. If this is a 0 cut, we just use this, right? We have this, and then we get it. Eventually, we will go to this is, and then yeah. So if this is a pattern, right? Something that this is a pattern. If this is a pattern, we add something to it. See, we can actually make it faster by adding another dp. Right, if it's a padding drum, it's not a padding drum, so we record it's not a padding drum. This is padding drum. This is not a padding drum. No. If we expand, it's not going to be a padding drum. So that actually can be simplified as well. So anyway, if it is a padding drum, if it's a padding drum. Alright, so here's what we're going to do. So I have a dp. This is called number of cuts from this one. Number of cuts from I to R. Yeah. Then is is POW. Is POW n minus 1 minus 1. If it is the last one is POW. Here. Right here. So right. Is POW n minus 1. So n minus 2. N minus 1. Right. It's gonna be depending on the, it's gonna be s minus 2 equal to s minus 1. Right. If these two same, then it's gonna be 1. If 0. Okay. So now we have this. I is going to be this to this, right? I'm going to say if so everything will be a new one. So let's go is palindrome first. This is palindrome, and dp is this. Dp equals 2, right? Equals 2. If it's a palindrome, then so if is palindrome plus 2 and minus 1. If it is a palindrome, that will be a 0 cut. Right? That will be a 0 cut. If it is a palindrome from this to this, it's a palindrome, that's a 0 cut. If it's not a palindrome, then it will be 1 cut. Now, for I minus 3, the range is going to be n minus 3 to the end. Right? So first, what we're going to do is for j. It's palindrome. You know what? The other one is good for I range and this palindrome I going to be right, let's say I smaller than n minus 1 and si equal to si plus 1. Then this palindrome I plus 1 is 1. So that covers the both situations. So now let's say for j. J is going to be I, so we're going to go I first. We can range I all the way. I with this and then this, right? J and then go all the way to N. Right? And dp I will be the same. Is POW. So now we're just going to figure out palindrome. Right, palindrome I to j. Right, I to j. And I to j could be the same. Right, so the I to j is already. Right, I to j is something we covered already. Perfect. And if not, then we can compute it. And if it's higher than 2, then we can go this and compare to get if it's palindrome. actually means, say, if I equals j, right, then this power j equals 1, right? This power ij equals 1, and then what? Out of I plus 1 equals j. Is power I j equals 1 if s I equals sj else 0. Else is parameter ij equals 1 if is parameter I plus 1 j minus 1 and si equals j else 0. And this is to find the padding group, right? Then once we find the padding group, we know padding or not. Then we say, let's change the padding group. Right? We say is padding group ij. So first determine whether si j equals 1 is the padding group. Cache it. Okay, so determine whether it's a padding group. And now, if si j equals 1 is a padding group, you compute the possible number of cuts. So it's a padding group. Right? The possible minimum of cuts. dp I equal to minimum dpi and dp plus 1 if I is smaller. Right? Actually, no. If I is smaller than n minus 1, because if I is equal to n minus 1, else, just like that's going to be 0. Now, this we're actually talking about. Don't have to do this. No, don't have to do this. Right? Is this j is I just go minus 1. Perfect. We start from n minus 1. From n minus 1. It will be the same. And then it is. Right. dp I just pass. So all we have to do is from here is padding group. If it's padding group, compute minimum dp dpi plus 1. The last one's different.
Mm.
Squared should be much faster. Yeah. There we go. Yeah. 1,000. Alright, that'll be it. I don't want to check the other one. It's pretty much similar, I think. DP. Yes. Pretty bad. I'll consider this one. I didn't solve it. I didn't solve it myself. My solution is not worth useful. This solution is. I mean, there are actually three important things. If we want to take the message, first is we're ending. Consider something ending at the end. That's important. No, that's actually not the most important. The most important is if we find something that is not a palindrome, we skip it. That is the most important part.